Morning, welcome to Lab 3 for working with spatial data for Geography 265. As you may have found out last week, finding different data sets is difficult. Sometimes it's in a non-spatial format, such as a .txt or a .csv file, as we did last week in Lab 2. And sometimes it's in a format more recognizable to GIS. Sometimes in a personal geodatabase, sometimes as a shapefile, and sometimes even as an interchange file format. In today's lab, we're going to be working with a variety of different spatial data downloaded from different clearinghouses throughout the internet. We will be using a variety of techniques to work with the data. We're going to convert some of it to formats that GIS can more easily work with to create a series of 5 different maps that you'll place into your lab assignment. For the first part of this lab, we're going to be working with a personal geodatabase from the Oregon Geospatial Data Clearinghouse. You type it in or click to bring. The Oregon Geospatial Data Clearinghouse has hosts a variety of information, including the Oregon Spatial Data Library, digital orthoquads, digital elevation model files, GIS links, services and tools, as well as the Spatial Data Library alpha list. We're going to go ahead and click on this. Once it comes up, we're going to click on the H and bring up the hydrological boundaries. Note when you're looking at the watershed boundaries data set and the hydrological units, it has a brief description of what the information shows. Note the scale. Note that there's no graphic preview. Note that it's a vector file with polygons. If you would like, you can click on the HTML or XML links to look at the metadata. If not, I suggest that you download the link. Download the link. This may take a few minutes, so be patient. Once downloaded, you'll unzip the WBD_Oregon. You may want to try to download the data twice in case it doesn't work. Mine took upwards of 11 minutes. Once downloaded, you can open your file in your Finder and be sure to drag it to your working folder. In this case, I'm going to be working off my desktop, which I advise you not to do if you're working in computer lab computers. Go ahead and open this data up in ArcCatalog. Remember, first, you'll have to connect to your folder to where you have your data stored. In this case, it's going to be the desktop, Lab 3 working. Now, some of you might click on the WBD or geodatabase, but if you click on that, you won't be able to access it. So be sure that the main umbrella folder that you're working under is the one for Lab 3. From there, you can click on your geodatabase. Note that there's 6 files, HU1 through HU6. In ArcCatalog, you can take a look at the preview of each file, as well as the description. Questions 4 through 6 ask you to look at the description. This is the metadata. Might tell you the summary, maybe some tags, the description, credits of who made the data, use limitations, the extent, and the range. Go ahead and browse through all of the metadata for HU1 through HU6. In your new ArcMap document, go ahead and add any two of these files from the geodatabase. Remember, there are 5 different ways to add data. I'm going to go ahead and drop and drag the data from ArcCatalog into ArcMap. Once in ArcMap, take a look at the data. Which file contains smaller boundaries, smaller regions? Is it fine data or is it coarse data? Lay the coarse data on top of the fine data. Change the color to hollow. And change the line size to 3 so it really stands out. Now you'll have the bigger boundaries laid on top of the smaller hydrological boundaries. Once you've completed this, go ahead and go to Layout View and create a map. Don't forget, as good practice would be, to get in the habit of inserting all the appropriate map documents, such as an appropriate title. North arrow, something preferably not too gaudy, very basic. And a scale bar. Be sure your scale bar is in appropriate units of measurements. Go ahead and have fun playing around with this. Be sure that your map looks neat and tidy, that none of the Borders bleed over the edge or bleed onto any other material. Once you believe that your map is complete, go ahead and export it as a JPEG. To do this, click on File, Export Map. Choose the file name that you would like to save it as, and then save as type JPEG. This can be imported into your Word document. Go and save your ArcMap document. For the second map in Lab 3, working with spatial data, we're going to work with a few coverages. Coverage is a data model for storing geographic features that both contains primary features such as points, arcs, and polygons, as well as secondary features like ticks, links, and annotation. Unfortunately, coverages cannot be edited in older versions of ArcGIS. However, we can use them in Arc 10.1 or Arc 10. As stated, unfortunately, these files are often very cumbersome to share, and so they're often stored as a GIS format of a zipped file. These are called interchange files, and they have the extension E00. In order to use these in ArcGIS, we'll need to unzip them using Arc. For this portion of the lab, we're going to go to the Regional Ecosystem Office website and download the late successional old growth data. This is another geospatial data clearinghouse. Scroll down to the late successional old growth. You'll see the short description says it is late successional old growth boundaries developed by FEMAT in 1993. You can view the metadata if you choose to click on it. It'll give you some information. Who created the information, what geographical extent it uses, the spheroid, and the projection. Go ahead and download the late successional old growth. This file should take slightly less long to actually download. Once download, open it up, and be sure that you save it to your working file. In this case, I'm going to copy it and paste it to my working folder on my desktop. Again, you'll be wanting to use your flash drive for this. Be sure that you extract this data. Right-click, Extract All. Open up a new ArcMap document. Now we're going to change this interchange file format to something that we can use in ArcGIS. In order to convert this, we're going to use some conversion tools from our Arc toolbox. Remember, the Arc toolbox is this red toolbox at the top. You can either click on that and access a variety of tools, such as the conversion tools. In this case, you would go click on the conversion tools, to coverage, and then import from E00. There's another way, as there's a lot of tools, things can get really confusing as the way they're nested. You can always go to the search tab over on the right-hand side. Click the search tab and type in exactly what you're looking for. In this case, it's going to be import from E00. When your search comes up, you'll note that it gives you, if you click on it, it'll give you a short description of what the tool actually does. This is your metadata for the tool. Sometimes this is nice to look at to see which files you'll be working with and what the actual output will be. Once you have your import from E00 or from interchange file format is ready, your input interchange file is going to be the file that you downloaded from the RIO website. In this, I'll be connecting to my Lab 3 working folder and click on the LSOG 194. Here, the only option that's available is the E00 interchange file format. Go ahead and double click that, and it should go into the top bit of information. The output folder is where you intend to save the data. You can save it as whatever you'd like. I suggest saving it as something useful that you might recognize later, like late_forests. Remember, working with ArcGIS, you never want to use any spaces or other punctuation in your names. So if you want to separate out information, be sure that you only use an underscore. You won't want to change the name on the output folder, you just want to change the output name. So leave the output folder as LSOG_194 and change the output name to what you want it to be. Click OK. Working with ArcCatalog, now our coverage should exist. If you look in your Lab 3 folder, you may have to actually refresh. To do that, click View, Refresh, or just click F5. Once you've confirmed that your new coverage has been imported into ArcCatalog, go ahead and import it to a new ArcMap document. Again, there's multiple ways of importing data. We're going to go ahead and use another one, using the Add Data button in ArcMap. Going to connect to my home folder and click on my late forests. If you double-click the late forest file, coverage file, you'll note that there's arc, labels, polygons, and clicks. Those are all the different parts of this coverage. If you highlight late forests and click Add, all of this information will be added to your map document. In order to see the data a little better, let's change the color to Sebel Orange. Again, you can double-click the color or you can right-click it and go to Fill Color. Sebel Orange is located in about the fourth color down, fourth column, fourth row. Change the outline color to no color. What you're looking at now are late successional old-growth forests in the Pacific Northwest, stretching from Washington almost to Canada down to northern. As we discussed in class, sometimes data doesn't really show much when it's just vector data or just a coverage. We're going to need some geographical context to actually see what we're looking at. ArcMap has these features called base maps, where we can add a base map that moves with wherever we're zoomed into on the map. To do so, use the Add button just as you would add data, but click on the drop-down triangle. Click Add Base Map. Because we're looking at forests, we will probably choose topographic, although there are a variety of options depending on the purposes that we'll be using the map for. The base map may take a few seconds to load, so be patient. Your base map may not load initially. You may have to check the World Topo Map box and uncheck it for it to show up. It's a big file. It's using a lot of memory, so be patient on these things. Our base map in this case is a raster file. It's using cells to show a more complete picture of the world that we know. Looking at the late forest polygons that we imported our coverage from, note where we're looking at. Using the zoom tool, go ahead and zoom in to your late successional old-growth forests. Maybe explore a section of the state or of the Northwest that you're familiar with. See where the old-growth forests. Look at where the late successional old-growth forests are. Do you see patterns? You can also play around with other base maps. Familiarize yourself with these. They can be useful in the future. Once you've played around with the base maps, go to your layout view. Zoom into a section of the Northwest that shows late successional old-growth forests, as well as your base map, and create a map. Again, add the appropriate map elements. For this map, you may want to actually insert a key. The map key is going to show you that the orange spots, or remember, if they're printed out on a computer that's just black and white, the continuous gray patches show late successional old-growth forests. Add a scale bar, add a north arrow. Don't forget to include metadata somewhere that includes who made the map. Hint, this is you. Export your map as a JPEG, import it into your Word document, and move on to digital elevation models. Again, the digital elevation model is a raster grid of regular space elevation values. Again, keyword here is raster. They're one of the most common digital data of the shape of the Earth's surface. We typically use these to represent terrain relief. We can see aspects, we can see different elevations, and things like that. In order to use a DEM in ArcMap, we're going to have to convert it into an ArcGIS raster grid format. What you're hopefully seeing in this lab is that lots of the data that we get isn't readily usable. ArcGIS provides many conversion tools to convert this data into something that we can actually use. For the digital elevation models, we'll be exploring a different geospatial data archive, or geospatial data clearinghouse. This case is the Washington State Libraries. Click on your link. For this lab, we'll be downloading data by geography. Note that it's organized in a variety of different ways. Click on data by geography. The lab will instruct you to choose Washington State. Once you're in the Washington State GIS data, you'll want to click on elevation data. It's going to take you to another bunch of options. For our purposes, we're going to be using 10-meter elevation data. Washington State hosted by USGS. There are a bunch of options once you get. It's going to choose from these grids, choose Seattle. From Seattle, search for Mount Olympus. It's going to be in the top left-hand corner. Once you click Mount Olympus, it's going to download. Again, it's a zip file with some archaic name that doesn't make any sense. Once it's downloaded, open up that file and copy it to the folder that you're working in. In this case, again, you should be working on your flash drive. However, I'm working on the desktop. Note that in your Windows viewer, your digital elevation model doesn't have much of a preview. In order to use this, we're going to go back to ArcMap. Now, instead of importing the layer direct away, we're going to have to convert it. To do so, we'll be using our Arc toolbox again. Again, using the conversion tools, we're going to convert from digital, we're going to convert to a raster from a digital elevation model. Double-click DEM to raster. Here, your input file will be the digital elevation model that you downloaded. Note that your output raster may not be to where you actually saved it. In this case, mine's in the Documents ArcGIS default geodatabase. I'm going to find the folder that I want to be working with and save this as something else. In this case, I'm going to call it Oli. Once I have my file name saved, I'm going to click OK. Well, this won't take very long. It's converting to a raster. However, your raster image doesn't really show you very much. In order to get more of a 3D feel to this, we're going to convert this raster to a hillshade. To do so, we're going to use your digital elevation model should be a raster grid of regularly spaced elevation models now. Now, to create the hillshade, we're going to have to turn on our Spatial Analyst tool. To do so, go to the Customize tab and click Extensions. Be sure that your Spatial Analyst extension is checked. Once checked, close the window. And in your Arc toolbox, go to the Spatial Analyst tools. Again, you can search for this as well in the Search tab. And click down to S under Surface. And Surface, double-click the Hillshade tool. Here, your input raster is going to be the file that you just created. In this case, for me, it's going to be Oli1. My output raster is where the file is going to be saved. Again, I want to be sure this is saved somewhere where I'll be working with it. I'm going to call this Oli Hillshade. Your azimuth should be at 315 and your altitude at 45. Don't change these. Click OK. Depending on the speed of your computer, this may take upwards of a few minutes. Once your hillshade has been created, you'll notice that now your map looks a lot more like real life, where you can see different elevation, you can see ridges, you can see valleys. Now, to complete your map, be sure that your grid layer is above your hillshade layer. Right-click, go to Properties. We're going to go ahead and change the transparency so that we can show the grid layer over the hillshade layer and make it look like more real life. To do so, right-click, go to Layer Properties, and under the Display tab, you can find Transparency. Turn the transparency down to 50. Click Apply. You should now be able to see your hillshade layer beneath your grid layer. Under Symbology, change the color ramp to something that looks a little bit more real life. Be creative. In this case, I think I'm going to choose this color. Click Apply. You should now have a map where your raster grid layer shows transparently above your hillshade layer. Go to Layout View and turn this into a completed map. Export it as a JPEG and add it to your map doc. For our fourth map, or part 4 of this lab, we're going to be working with digital raster graphics. According to GIS Data Dictionary, a raster graphic is a raster image of a scanned USGS standard series topographic map, including the original border information, referred to as the map collar, the map surround, or the marginalia. For this data, we're going to be going to the Geomorphological Research Group website. Again, Control-click to follow the link. Under the locally hosted GIS data, click Raster Data. Once you're in Raster Data, we're going to be working with images. Remember that, again, the digital raster graphic is a scanned image. Under Images, click Digital Raster Graphics of the 24K, 100K, and 250K quads of Washington. Downloading the data here looks very similar to the DEMs that we downloaded in the previous section of the lab. Click Vancouver. Click Vancouver again. This should download another zip file of the information for the digital raster graphic of Vancouver. Go ahead and open this up in your Finder, unzip it, and drag it to the folder that you'll be working with. Once it's copied to your folder, extract all the files. Now we'll be ready to use ArcMap. In a new ArcMap document, add your new data set. When asked if you would like to build pyramids, click Yes. Building pyramids allows you to zoom in and zoom out. So when you're zoomed out to a coarse resolution, your data will display coarsely. And as you zoom in, it will get finer and finer to represent successively smaller areas. Once your map has been added, go to your layout view and add the latitude and longitude graticules on your map. To do so, all you have to do is right click and go to Properties. Go to Grids, select New Grid. From here, the Grids and Graticules wizard will guide you through the process. In this case, I'm going to be using longitude and latitude. Click Apply and OK. Now you have a grid around your map where you can measure different coordinates. From here, zoom into the island in the middle of Lake Vancouver. Find out what the coordinates are. The lake's going to be in the middle left-hand side of your page. Add the appropriate map elements, scale if necessary, north arrow, title, and name. Export as a JPEG to your map document. Export as a JPEG and insert into your Word document. For the final part of this lab will be georeferencing. Here we're going to take a digital raster we're going to take a plain scan map and turn it into a digital raster graphic. To do so, we're going to find known spots on our scan map and match it up with a known river system, the Niger River. Remember, this is a raster image that doesn't have any spatial information associated with it. Think of it as just a plain scanned topographic map that was once just on paper. However, once we're done georeferencing it, all of the points on the scanned paper map will be a digital raster graphic, and each one will have a coordinate reference. Now, in order to complete this part of the lab, please check the final email that I sent out on Thursday morning at around 10 a.m. This should be a zip file that says fall12/lab2. In this, you'll be using part 3 of the data. Once you've downloaded this final data package, fall12/lab2 data, going to go to part 3. First, add your rivers. This is a shapefile of the rivers in the Sakhalin Island in the Russian Far East. These are already referenced. Next, add your topographic image. If you double-click, it'll take you to the band layer. But we'll want to add all bands. So just click it once. Again, creating pyramids allows you to have, when you're zoomed out, to have a coarse amount of information. And as you zoom in, it's going to get finer and finer. This helps with processing speeds. Before it adds to your map, it's going to inform you that it is an unknown spatial reference system. Again, it cannot be projected because there is no reference system, which is what we'll be doing when we are georeferencing. Once your Kura-Nicha topographic map has been added, you won't necessarily be able to see it. You right-click and zoom to the layer, it'll take you to that map layer. Again, they're not lined up because this map is not referenced. Before we begin georeferencing, let's take a look at the spatial reference system or the projection of the rivers shapefile. To do so, right-click, go to Properties, go to Source. If you scroll down under Data Source, it'll tell you that the projected coordinate system is the WGS 1984 UTM Zone 54 North, and the geographic coordinate system is GCS WGS 1984. These two pieces of information comprise the spatial reference system of the river's shapefile. We'll talk a bit more about GCS and projections next week. Go ahead and click out of there. Now, in order to use the Geoprocessing Tools, we'll need to add the Geoprocessing toolbar, or Georeferencing toolbar. Go to Customize tab, Toolbars, and choose the Georeferencing toolbar. Your current isotopo should be the georeferencing layer that you'll be working with. If your current isotopo is not there, you can click on the drop-down box and add it. Now, these two pieces of information, the raster of Current and the rivers file, do not line up. In order to line these up a little bit to begin with, we'll click under Georeferencing, Fit to Display. Fitting to the display should put your current isotopographic map in the same general area. If your current iso did not fit to the display automatically, you might want to zoom into your rivers and then fit to display again. You should see a large river system overlaying a small map. Now to begin, we're going to have to find this river system on the actual topographic map. Again, these are not even close to the same scale, so we're going to have to shift, rotate, and scale these to get it to the approximate size. On the right-hand side of your georeferencing toolbar, there is the Rotate, Shift, and Scale tool. I'm going to begin by scaling this map down, scaling this map up a bit. Remember, you're working with the topographic image and not the river system. So let's make our map a bit bigger so that it's a little bit closer to the size of what we think our river system might be. Then we're going to shift this. We're going to shift our map to where we think the river system might be. Piece of advice when referencing these two pieces of information. Look at the eastern end of the river system. Note the little squiggly that looks like an upside down S. This is a really distinct feature, so we're going to want to match up this distinct feature with another distinct feature that looks similar on the topographic map. It's going to be on the eastern end again, so shift down your map and look at the rivers that are entering the bay, the ocean. Towards the top right hand corner of the map, you'll see the Niger River. Note again that upside down S. We're going to try to match these two up as closely as possible. You may find it helpful to change the color and the width of your lines so that they stand out a little bit more. Once these two systems are roughly lined up, we can now add some reference points. Reference points essentially peg the points in the river and the topographic map to points on the river on the actual shape file. Eventually, these files will line up and the rivers will take shape, referencing our entire. For accuracy, once your map's mostly lined up, you may want to turn your line width down. Now let's add some control points. Control points can be loaded to the right of the current topo on your georeferencing toolbar. Now to add a control point, you want to zoom in as far as you can. Find known spots on the river. To add a control point, you'll need to click twice. So begin by left-clicking on the actual topographic image in the junction of a known point, say a Y in a river. And then zooming in, find a similar point on your shapefile. Left click again, you should see your rivers snap into place just a little bit. Now, if you accidentally click in a point where you don't want to add a georeferencing point, you can right click and cancel that point. You want to add about 20 points to this map. Try to spread them out as much as you can throughout the map. Go from the left side to the right side, from the top to the bottom. This will keep your map from being too distorted. Again, click twice and your map's going to slowly line up. You can use the scroll button on your mouse to zoom in and zoom out. If you've added some control points and your map begins to take a shape, begins to look distorted, you can always delete those control points. To do so, go to your link table. It's on the right-hand side of your georeferencing toolbar. Here, you can see all the different control points that you've added. You can highlight them and delete them if you need to. However, before you get too carried away, don't forget to deactivate your snapping. This is going to allow you some finer control over your areas of interest. To do so, find your toolbar, find the snapping toolbar under the Customize tab, and be sure that Use Snapping is unchecked. I've already done this, so mine has already been unchecked. Add some more control points. After you've added about 20 control points and you're happy with the way your map looks, again, you may want to change the line so you can actually tell. Go ahead and under your georeferencing toolbar, update your georeferencing. Now you'll have a georeference. Once you've updated your georeferencing, you now have a scan map that is a digital raster graphic. Go ahead and in layout view, add the appropriate map elements. Be sure that I can see the river systems and that they line up. Add your name, add a title, all the other appropriate elements that you find necessary. Show me what this map shows. Export as a JPEG and insert it into your Word document. Once completed, this lab should contain 5 different maps, all with the appropriate map elements. Next week, we'll work on projections and geographic coordinate systems. Stay tuned.